All right, in this video, we're going to be talking about the metric system. We're talking about a new chapter, chapter 7 now. We've moved out of the algebra. Now we're into a new topic, and that's how we'll do in this class. So if you've printed off your note packet for chapter 7, please follow along with that. Or if you're just reading it online, follow along, though. So there'll be some practice problems I'll ask you to do along. All right, so just some talk here about the metric system. On the first page, you see it says the United States is the only major country not currently using the metric system as its official measurement system. We use the metric system intermittently, such as we have 2-liter bottles of pop, we all know that. We use gigabytes on our computer, like a 500 gigabyte hard drive, and we use milligrams for our medicine. But we still sell gasoline in gallons, and we can our beans in quart jars, and we drive in miles per hour. So due to the growth in a global economy, it can be confusing. Have you ever crossed the border to Canada or Mexico and suddenly realized all their units are metric? Everyone else drives in kilometers per hour. If you're going into the medical field or the science field, or most fields in general, you must know how to convert within the metric system. It's actually so much easier than our old English system. All right, so just some terms here. The metric system is the one I said is everywhere else, the metric system or the SI system. And then I'll refer to the old English system or the U.S. customary system as our quarts and gallons and miles and inches and feet are the old English system. For example, some of those things came from the old English system, like I said, because it said that like the king stretched out his arm from the length of his nose to his finger and said that would be a yard. You may have seen people like someone who sews kind of estimate a yard of fabric by holding a piece of the fabric and then stretching it out to the end of their arm, and that's about a yard. So that's where some of these things came from, and that's why they're kind of a weird measurement, not nice increments of tens or something, but odd numbers like 12 inches in a foot. So anyway, old English system. But it's what we're used to, and it's what we understand and know. It's whatever you've gotten used to. All right, so in the metric system, we will use one base unit to measure, like in length, it's the meter. And then we add on prefixes to change it in units of 10. In the U.S. customary, there will be inches, feet, yards, and miles, for example, for measuring in length. If we want to change 12 miles to inches, it's a pain. Do you know how many inches are in 12 miles? We could figure that out, and you might argue you can just Google it now, but anyway, there's some math to do that. But in the metric system, we only need to move the decimal point to change 12 centimeters to kilometers. So it's going to have the number 12 still in it when we convert within the metric system. It keeps the same numbers, we just move the decimal point. So much easier. Therefore, less fractions too. We won't have to get into fractional amounts. We're just moving this decimal. So everyone will like that, no fractions. All right, so 7.1, we're doing 4 sections of chapter 7. 7.1 starts with just the basic terms. So meter, the first term you'll see here, it's meter, which we'll abbreviate with the letter M, is commonly used to measure length. It is a little longer than a yard, close to 39 inches. And we know our yardsticks, if you have a yardstick at your house, and so I said here, look around your house, and I just wonder if you have a yardstick in your house, or if you have a meter stick, or both maybe converted on one side and the other. Some will show it on both sides, one way and then the other. But a yardstick is 36 inches, again, about the length of your wingspan there. And then a meter stick is a little bit longer. It's like 3 inches further. So just a little bit longer than your yardstick. So you may have either one of those, and so just ask you to think about that. But anyway, regardless, that is the basic unit of length measurement in the metric system is a meter. So we'll build off that. Then the next one is kilogram. A kilogram would be a kg, and that's commonly used to measure mass. The difference in mass and weight, by the way, is that mass does not change due to gravity, but weight varies. Like all my mass here would be the same. My mass does not change whether I'm here or I'm on the moon, but my weight would vary, right? So we know the pull of gravity is what makes something weigh a certain amount. But anyway, for our purposes, we'll just kind of assume and use the terms interchangeably. But know that your math teacher knows there is a difference between weight and mass. But if we're all on Earth and got the same pull of gravity, it's basically the same measure. And then the third term is the liter, L. And we use the liter when we're measuring capacity, like the liquid capacity of something. And we're all pretty familiar with that because of our liters of pops, right? You know, like 2-liter bottles of pop was the most common. And then I know now a lot of individual drinks are just in 1 liter or 1.5 or something. But anyway, so you kind of know what that liter looks like. That's the base unit for volume, for measuring liquid volume. 1 liter is a little more than a quart. If you've ever had a quart of beans, like when you're canning, anybody in your family cans beans, we kind of know what a quart looks like. And a quart and a liter are similar measures. The gas tank may hold 50 liters of gasoline, which would be about 13 gallons of gas. And so 50 liters, 13 gallons, similar measures. And we'll discuss how to convert, because that's something we'll need to know, is how do we, if we do have something in liters, how can we express that in gallons? How do we convert between those? So that will be in 7.4, actually. It's the last thing we do in this section. And that's the hard part, is converting between metric and English, because that will involve fractions and be more difficult. But 7.1 through 7.3, we just focus on converting within the metric system, which is lovely. We're just going to be moving our decimal points. All right, so next, the root words from above would be meter, gram, just the G. You know, kilogram is kind of the more commonly used measurement because it's still a pretty small measure, but the root word will be the gram, just the G, and then liter. So meter, gram, and liter are kind of the root words that we're going to be using for our purposes. These will be the building blocks for our conversions. Then we'll add prefixes to move the decimal point. All right, so we've got these basic units of measure, and you can see in my demo here, I've got your base unit will be either the meter if we're measuring length, liter if we're measuring volume, and gram if we're measuring that weight, how much something weighs. Then we put prefixes on this, so the base unit, either M, L, or G. Then the prefixes will be deca. Deca means 10 times that, 10 times that. Hecto means 100. So if you had a hectometer, we don't use that term that much, but just in theory, a hectometer would be an HM, and it would be in 100 meters. If you did like this, did that 100 times, that far out, that's a hectometer. A deca, D-E-K-A, a decameter will be 10 times, 10 of those meters. So, you know, maybe the length of your room, of a normal sized room, is a decameter. All right, and then lastly, kilo is 1,000. We use that one, it seems like, more often, so you might be more familiar with kilo of the unit. But like a kilometer, we a lot of times say kilometer, so kilometer or kilometer is a km, and that's similar to our miles. If you're using a unit for mileage, miles or driving a longer distance, you'll probably use kilometer. And then KL would be a kilo of liter, 1,000 liters, and KG, 1,000 grams. So even 1,000 grams isn't very heavy. It's still close to about two of our pounds. So 2 pounds, you know, not very much weight. So even 1,000 grams, because a gram is such a tiny, tiny measure, it's almost undetectable weight in your hand. So even 1,000 grams is still pretty small measure, but that's how it is in this conversion. All right, then if we get smaller down the list, DECI, the deca, means dividing by 10 or 1/10 as big. So if we took our meter stick, you know, our distance from here to here, and we divided it into 10 equal slices, you know, I've kind of got these little rows on my arm already. I've got more than 10 though, I think. But that would be about, one or two of these would be about a decimeter, a tenth, 1/10 of a meter. And then a DL, a deciliter, a tenth of a liter, and a DG, a decigram. Now the way we're going to differentiate, because both of these are D words, is deca will have a DA. So a DAM is a decameter. A DAL is a decaliter. Regular D is deci. A DM is a decimeter. And a DL is a deci. Everything else has a different first letter except these two D's. So again, the deca, the one that's 10 times, is DA, and the deca is regular, just D. And then we've got centa. Centa means dividing by 100, 100, so it's very little, kind of like an inch. And then milla. Milla is a thousandth, so very tiny. A millimeter is almost, I can't squeeze my fingers, that's almost microscopic. It's very little, millimeter. So very detailed measurement there. All right, next note, there are infinite additional prefixes. So just to note, these are the ones we'll mainly be using for our class, but we could go on and on this way and this way. There's infinite prefixes, and in your textbook, you might look through the textbook and notice there's a nice chart that shows some of the other prefixes just to be aware of. Some that you might recognize because of our computer age, we've had the need for some much smaller measurements and much bigger measurements. So, you know, let's see, mega million, like it means mega is 1 million times the base. Mega means a million. And then we have giga. Giga is 1 billion times the base. Billion, you know, that's pretty big. But then we have tera. You hear that? Terabyte. A tera something is 1 trillion times the base. So lots big, right? Then on the other end, things are really, really tiny. We have nano is 1 billionth divided by 1 billionth, 1 billionth of the base. So some tiny measure. You know, if I think millimeters little, imagine a nanometer, you know, super tiny, 1 billionth smaller. All right, so, but like I said, we don't use those so much for our purpose. If we just get this down pat, that's our purposes for this class. As everything we do in the class, we scratch the surface of many math topics. It's kind of a survey class of various topics in math, just kind of whet your appetite. And you can take any one of these subjects and go much deeper into it. So keep that in mind. So we're just kind of scratching the surface of each topic we go through. All right, so next note. We simply move the decimal point as we move up and down the scale. So as we go up the scale, if we were moving from a deca to a deca, we would go up the scale, we would move our decimal point to the left. If you're moving down the scale, you move your decimal point to the right. For example, 457.3 in meters will be what in kilometers? So again, each one of these is a tenth, multiplying or dividing by 10. If we're going up the scale, we're dividing. If we're going down the scale, we're multiplying. So up the scale from meter to kilometer, we're starting here, and that does count as a place. We're going 1, 2, 3 places up. We're going to take this decimal 3 places left. And that'll put the decimal in the front of that, like so. Note that the number of moves from meter to kilo, that was 3. Count the spot you land on, so that is 3 moves up the scale. So up is left, down is right. Okay, so one more. We've got, on this page, we've got convert 14 grams to how many centigrams? From grams to centa. So gram is also on the base unit level, so these are all the base units. So we go from here to 2 places down to centa. So that's 1, 2 places down. Down is right. So where's the decimal? If you don't see it, it's at the end, the last of the after the last number, and then we move that 1, 2, which will fill in 2 zeros and make 1400. Okay, next example, we've got 0.98 liters. We want to convert that to milliliters. So we're going from liter, which is on that base unit, 1, 2, 3 down to milliliter. ML would be the milliliter. So that's 3 down, so 1, 2, 3 places. And the 0 in front, you can kind of just knock that off, or you can put it if you want, it wouldn't hurt anything. So 980.